All right, everyone. Thanks for joining me. My name is Markus. I work on the Android SDK at Sentry, and today I will talk about Canvas APIs. Before we get started, a few words from your sponsor. Sorry, you can't skip this ad, but it's short, just 2 slides, so please bear with me. So what is Sentry? It's an error and performance tool for tracking your performance and also monitoring all the metrics which are important. It's built by developers for developers. It's open source, so you can access our SDK on GitHub, but we also develop out in the open, so you can contribute and even open a pull request on our repos. And it's also free, so not only our SDK is open source, but also our backend, so you can self-host Sentry. Of course, you can then also use a cloud offering, which we have, which again has a free plan, but then there's also a paid plan. When talking about Sentry and Android, here I just have a few screenshots here. So what you get out of the box for example, error monitoring, besides your stack trace, we also enhance the stack trace with context information. In this case, we can attach a screenshot, so you see what happened when the crash occurred. But we also add device details. We also have an option for adding the view hierarchy to every event, so you see really what was going on. We also have a feature called breadcrumbs. So this gives you a trail of events to better understand what led up to a certain crash. This is quite useful when you want to reproduce something. We have tags and tag analysis. This can be useful for situations where a bug maybe only occurs on a specific Android OS version, or maybe a specific app release or certain devices. And we offer this all out of the box. On top of that, we have a performance offering where we, especially on Android, have some really good built-in integrations for OKHTTP and Room. So any database query you are performing or any network request you're making will show you the slow and fast parts of your app automatically. And if you want to dive even deeper, you can also use our profiling offering, which gives you performance details down to a code path level. And we do all of this not just for Android, but pretty much any SDK I could think of. So if you name a language and a framework, we probably have an SDK for you. We also have a booth down there, so feel free to come by and chat about Sentry. Yeah, so why on earth would an Android engineer working on SDKs give a talk about Canvas when he doesn't do UI on a daily basis? And the background here is something called Session Replay. It's quite popular on the web, and it gives you a video-like replay on how the user was interacting with your app. And we had this idea of doing the same thing for Android. And the first approach we took was a few months ago, and the goal here was to kind of record and replay all the different Canvas commands. So in your traditional application UI, whether it's written using the layout XML files or Jetpack Compose or even React Native on Android, at some point you would use the Canvas API to draw your lines and shapes onto the canvas. And now we would come in and kind of intercept this. So we would install a canvas recorder, which takes all the canvas commands and on the one hand side forward the commands to the original canvas. We still want the pixel to be drawn, but on the other hand side also save the commands into a recording, so you could later then maybe browse on sentry.io and replay the recording and see what was going on. I talked about the canvas now already a bit. What is it anyway, right? It can be best described as the drawing context. So it's not just an API for calling .drawLine, but it's also a certain context which is basically the state of your canvas. It's backed by the Skia rendering engine, which is written in C and C++, and also not just used for Android, but also for Chrome or even Flutter, although Flutter is moving to something new these days. And every API at least most of the APIs you are using, actually have a native counterpart. So if you're using Canvas in your Java or Kotlin code, there's actually a native C++ Skia Canvas class, which is the counterpart, and the same is true for the metrics or the paint. What's important to note here is whenever you try to draw something onto the canvas, it's not just the drawing command itself, which defines the pixels, but the overall state of the canvas. So whichever transformation you're applying, whichever clipping is set, whichever paint object you're using, they all influence the final outcome. And to better manage this canvas state, there is even a checkpoint-like API. So maybe you've seen this one. It's canvas.save and restore. There are also a few variants of those. And they allow you to kind of have a checkpoint and go back in time. So in this code example, you can see here we have a canvas.save call, followed by translate and a scale. So we change the state of the canvas. And now we could either reverse those operations or simply call canvas.restore. So this resets or kind of discards the scale and translate operation here, and we get back to the state as it was at the point we called .save. And usually you don't always need to use save and restore on your own. So here I have a Jetpack Compose example. We have a canvas, and inside our draw scope, we call a save function, which accepts a code block, where we actually just draw some circle. And what's interesting here is that under the hood, you will see you would still have a save and restore call. It's just hidden for your convenience, basically. The Android Canvas API is huge. There are many methods in there. And there's a reason for that, and that's performance. So there were a few different strategies used to improve the performance, because we want to make drawing fast, right? And one of the strategies is to avoid object allocations by simply providing multiple method overloads. So here we have canvas.drawRect, and then there's an overloaded method, which instead of taking a rectangle object, just takes the raw pixel coordinates. This can be useful in a situation where you manually calculate the x and y coordinates and have them as variables, so there's no need to wrap them inside a rect. This actually makes even more sense when you look and dig down into the source code. So canvas.drawRect is actually just making a supercall to our base canvas. And here we see a n drawRect. The n stands for native here. So we are already going down into the native layer by making a JNI call. And here the rect is anyway disassembled into the left, top, right, and bottom coordinates. So there is not always a need to create this rect object. And this way you save an object allocation. Another strategy which is used, that's more like on the getter side, is to simply reuse objects. So instead, within your tight drawing loop, instead of creating a new object every time and doing the object allocation, you simply reuse an existing object. So here we have canvas.getClipBounds, which returns you the current clipping region as a rectangle. So this would already create an object allocation. But then there's also an overloaded method where you pass in an existing rectangle. And this way, you have a slightly optimized code. Then there's a third strategy which is being used, and that's bulk operations. That's rather rare, but there's still a few occurrences in the API. And here we see a canvas.drawLine, which draws a single line. And then there's another method called drawLines, which allows you to draw multiple lines in a single pass. The goal here is not to avoid object allocations, but to rather avoid the number of times you have to make the JNI calls, because that also comes at a certain cost. A good example for this would be maybe a charting library where you draw some grid in the background, and instead of drawing the grid line by line, you can do it in a single pass. Now we want to have a look on how those canvas operations are being performed out in the wild. So I came up with this crazy example of a button centered in a frame layout. And we can have a look by using our canvas recorder to see what's going on under the hood. So here I'm just plotting like the output of my canvas recorder here as some text, and let's go over it step by step. It all starts out with a save command followed by a translate. So we had some layouting and measurement going on before, and we are now moving the origin of the canvas to the location of the button. What's up next is drawing the actual background of our material button, which is in this case this purple pill. So we have another save command and a clip rect command, which just ensures that the drawable of our button is only drawn within the clip bounds. Then we finally have this draw around rect button, and the background more or less is done. And now this is followed by a restore. As you remember, restore goes back to the last saved point, which in this case is mainly discarding this clip rect f call, which we had previously. Now we need to draw the foreground of our button, which is in this case the text. So we have another save call, another clip rect, now really clipping to the area of the text itself. Then we see a translate call, in this case even translating to the bottom left coordinate. That's simply because the Canvas Draw Text API draws the text at the baseline. So we want to move the canvas to the baseline before we finally call draw text. And now our button is already done. We have now one restore step, which discards the previous translate and clip rect, and then followed by another restore, which finally gives us back the original state of the canvas. In total, that's just 12 drawing commands, so that's not a lot, and our button is drawn, which is good. And you maybe can guess it, I did the same for Jetpack Compose. Maybe you can do a little guessing game, how many times less or more drawing commands are being performed. I have kind of bad news, it's 49 calls, so it's way more. I really don't know why, but on the positive side, there's room for improvement, right? And it's probably also, it's a really bad example for comparing a performance of two engines, I would say. And also there's one difference. Jetpack Compose, the surface draws the actual background, whereas in the Android View system, this is done by the Android system, so it takes the CMXML and uses the window background attribute to draw the whole window background for you. So there's also a difference in the implementation, so it's definitely not a fair comparison, but still interesting to see. Now I want to show some more concrete examples on ways you can use the Canvas API, which maybe you haven't seen yet. So here we are tasked with drawing some fancy monthly expense report, and our brilliant designer came up with the idea of doing a bubble chart. So we have some fancy colored bubbles on top, and the bigger the bubble, the more it takes from your monthly expenses. We also already have a data model, so we have items, maybe they are coming from our database. They have the label, the color, the icon, and the share value. And then we have bubbles, which is already something we can maybe draw onto the canvas, as they already have an X and Y coordinate, a radius, and also the item as a payload, so we still know in which color to draw the bubble. We also found some algorithm on the interweb on how to kind of lay out those bubbles. So we have a bubble packer, it takes in those database items and transforms them into bubbles. Now we face a very classic problem. The space in which our bubbles are packed are different from what we need for Android. So the bubbles in our case are centered around 0, 0, and the top right corner is at 1, 1. Whereas on the Android View system, drawing always, the origin is always the top left, and the canvas width and height is at the bottom right. So how can we do that? So we could now brush up our math skills and do what we learned, or we can be lazy. In this case, we can use the metrics.setPoly2Poly method, and it has a very nice idea. You pass in points from your source space, and then you pass in the points from your target space, and it will automatically set up the metrics for you in a way that you can make the transformation from one space into another. So we need a few points from every space, and in this case it's rather easy. We can just take the bounds. So we use the top left coordinate, the top right, bottom left, bottom right for both spaces, and we automatically get a matrix which we then can apply. Now there are two routes we can take. We can either set the matrix directly onto the canvas, or we can call matrix.mapPoints to map every individual point. And what's a canvas demo without any animation, right? So our designer also came up with the idea that we need something fancy, so we have the bubbles magically moving towards the center and rotating at the same time. We again can use the Matrix API for this. There's just one trick we need to apply here, and that's inversing the current animation progress, because usually you have a progress starting at 0 and ending up at 1. So invert that, so it starts at 1 and ends up at 0. So this way we can have a rotation at the beginning, and as we are moving towards the end of the rotation, we have it at 0. And we can actually apply both for the rotation and for scaling. So we use matrix.postRotate to perform the rotation. What's important here is also to define the pivot point, which is in our case the center of the canvas. So we rotate it from the center, and then we also scale it from the center, and we end up with an animation as we can see on the top. This is still quite interesting because we just draw circles and it already looks kind of cool, right? But there could be so much more to explore, starting maybe from using gradients to render effects or even shaders. As a last step, I also just quickly want to show on how those bubbles are drawn. We just need to iterate over those. We take the X and Y coordinates from our bubble. We use this animation matrix, which is filled with the current state based on the animation progress. We map the points, we get back the X and Y coordinate, and we can finally call draw circle. That's already the end of the presentation. I hope you learned something new or got some inspiration. Here are a few resources. If you're curious about what we are up to next and you want to have session replay on Android, feel free to follow us along on GitHub. Thank you very much.